Okay, this is the CCEA Maths M7 paper 1, so the non-calculator paper, and this is from 2021. So let's take a wee look at the first question. On the grid, enlarge the shape with a scale factor of 2. So we need a ruler for this one. We can do it anywhere. Some of them you need to enlarge about a certain point, but not in this one. So this here is 4 squares, so we need to do then an equivalent only with 8 squares. Let's see, hopefully it'll fit in okay. 1, 2, 3, 4, 5, 6, 7, 8. And again, my advice would be to do it nice and clearly and nice and heavily. This is across 2 and up 2, so we want to go across 4 and up 4. This line here is across 2, so we're going to go across 4. Then it goes up 2, so we're going to go up 4. And then across 1, up 1. So we double that because we're a scale factor 2. And then effectively we just join the start to the end, although it is across 3 and down 1. So we go across 6 and down 2, and that's our new shape there. How many times bigger is the area of the enlarged shape than the smaller shape? Well, the scale factor of the lengths is 2, so the scale factor areas is going to be 2 squared. So the answer to that one then would be 4. Number 2, which of the numbers below shows that the following statement is not true? If p is any odd number, then p plus 2 is always a prime number. So here we have an odd number. Whenever we add 2 to it, it's 3, so it's a prime number, so it's not that one. 3, when we add 2 to it, is it 5? This is a prime number. 5, when we add 2 to it, prime is 7, which is a prime number. 7, when we add 2 to it, it gives us 9, which isn't a prime number, so that's our answer there. Okay, change 20 miles an hour to kilometers per hour. We want to divide by 5 and times by 8 is generally our method for this. So 20 divided by 5 gives me 4, and 4 times 8 is going to be 32 kilometers per hour. In a year 12 class, the following information was recorded. 3 boys wear glasses, 5 girls wear glasses, and these ones then don't wear glasses. So what fraction of the pupils wear glasses? So we have 3 and 5 here, which gives us 8, and there's a total of 16 plus 8, which is 24. So it would be 8 out of 24, and that cancels down then to a third. A pupil is chosen at random from the class. What is the probability that the pupil was a boy who does not wear glasses? Boy who doesn't wear glasses is 10 out of 24. So 10 out of 24. They both divide by 2, which would give me 5 out of 12. The next week a new boy joins the class. He wears glasses. Will this change the probability of now choosing a random girl who will wear glasses? Yes, it will, because it was 5 out of 24. Answer is yes, because change from 5 out of 24 to 5 out of 25, because there's now 25 pupils in the class. Sam and Julie share £35 in the ratio 6 to 1. How much is each share? The wee secret to this one was you do 6 plus 1, which is going to be 7, and we then do 35 divided by 7, so that's 5. We times each of these in by 5, so it's going to be 30, and then 5, of course 30 and 5 out of the 35, so we've got it right. Sam was the first one, so he needs to be the 6th part, so he will be 30. and then Julie will be 5. Question 6. Look, Dad, said Aaron, here all the silver coins from my piggy bank. How much have you got? Said Dad. A third are 5p coins, a quarter are 10p coins, and the other 10 coins are 50p coins. Said Aaron. What is Aaron's total amount of money? So there's a wee bit to do here. If a third are 5p and a quarter are 10p, if we add those together and then take them away from 1, that's going to give us the fraction of the 50p coins. So we want to do a third plus a quarter. And if you add those together, you want to change you want to get a common denominator, so it's going to be over 12. So times by 4, so it's going to be 4/12 plus 3/12, and that's then going to be 7/12. Therefore, 7 taken away from the 12, 5/12 are 50p's. So 5/12 equal 10 coins. That means 1/12 must be 2 coins, which means a third, which is of course 4/12, which is going to be 8 coins, and a quarter, which is 3/12, would be 6 coins. So the total amount of money, a third are 5p coins, and a third is obviously the 8 coins. So we have 8 times 5p, which is 40p. A quarter are 10p coins, and a quarter is 6. So 6 10p coins, that's 60p, and then there's 10 50p coins, which is obviously 500p or £5. So the total then comes to £6. A, B, C, D, E is a pentagon. Lines AF and CG are straight lines. Work out the value of x plus y plus z. So x plus y plus z. A couple of different ways of doing this. If that's 50 and that's a straight line, then that must be 130. It's a pentagon, so the angles in a pentagon add to 540. So that means x plus y plus z plus 130 plus 115 equals 540. So that means x plus y plus z is 540 take away, and then 130 plus 115 gives us 245. And that equals then 295. So my answer to this one then is 295. You can split it up into kind of 3 triangles. That'll help you know that it does come to 540, and that's actually the way I thought in the mark scheme, but the way we've done it there then is fine. Let's go on then to question 8. Simplify each of the following. So 4p cubed times 3p to the power of 4. I would just take each wee bit separately. The number bit, 4 times 3 is 12. P to the power of 3 times p to the power of 4. Of course, we add the powers there, so it's p to the power of 7. Q squared all cubed. That's our third rule of indices, so we multiply the 2 powers there. So that's actually q to the power of 6 divided by q to the power 8. We now subtract the 2 powers, so we would get then q to the power of minus 2, or if you want, 1 over q squared. And those are fine. Question 9, find the nth term of the sequence. So I always number them 1, 2, 3, 4, and then I find the gap, and the gap each time here, it isn't 3, be careful, it's minus 3. That means my nth term is minus 3n plus or minus something. I substitute the number 1 into this formula. Minus 3 times 1 gives me minus 3, but I want 7. So it means then I need to add 10 to it. So my nth term is minus 3n plus 10. Question 10. Tony tests a 6-sided dice which he thinks is biased towards the even numbers. He carries out an experiment by rolling the dice. He records the results as even or odd. What is the relative frequency of getting an even number? 1, 2, 3, 4, 5, 6, 7. And he rolled the dice 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the answer would be 7 twelfths. How could Tony improve the experiment? Obviously, I guess just kind of do more trials. It's very hard to tell, with just kind of 12 rolls of the dice, kind of whether it's biased or not. So if he rolled it hundreds of times, then that's going to improve it. Question 11. Make y the subject of this formula. I would be adding 12 to both sides. We effectively want to get the y on its own here. So if I add 12 to both sides, I would get 3y equals 4x plus 12. I then divide both sides by 3. And I get y equals 4x plus 12 over 3. Which is an acceptable answer, 4x plus 12 over 3. Another answer, incidentally, if you get this, you're okay as well. 4x over 3 plus 4 is also okay. A rectangle has length 3x and a width of x plus 5. The length is greater than the width. Write this information as an inequality. Well, they're saying that the 3x is bigger than the x plus 5. So that's all you have to write. 3x is greater than x plus 5. Solve this inequality. I would subtract x from both sides. We want to try and get it so it's x and then the symbol and then a number. So I would take away x from both sides. That gives me 2x is greater than 5. And then divide both sides by 2. And I get x is greater than 2.5. So x has to be greater than 2.5. Show your answer on the number line below. So I would go then to 2.5. It can't be 2.5, so it has to be one of those open circles that looks like that. And then anything in this direction here then is fine. Question 13. ABC is a right angled triangle. Work out the length of AB, giving your answer as a third. Goodness. So we have this side here. I sometimes find the A, B and C here a bit confusing because I label my Pythagoras ones A, B and C is the longest side. So that's C and the A and the B don't matter. So I'm going to call that one A and that one B. So I know C squared equals A squared plus B squared. I know 11 squared equals A squared plus root 19 squared. This is a weird one now because I've said the square root of 19, so we need to think about that. 121 equals A squared plus 19 square root and then squared actually is easier for us. It's just 19. If you find the square root of 19 and then square it, you just end up then with 19. That means our A squared is 121. Take away 19. Be careful there, don't be adding those two numbers together. And that gives me A squared then is 102. And A then is the square root of 102. So my answer then is square root of 102. Question 14. PQR is a right angle triangle. So that's the big triangle here, PQR. And QS is a perpendicular line from Q to PR. Prove that the angles PQR and QSR are similar. So proving that the triangles are similar, you can either show that their angles are the same. If their angles are the same, then they have to be similar. Or that their sides are in ratio. We don't have any sides here, so we just need to kind of look at the angles. Alright, I can see that PQR is a right angle. PQR shows you it's a right angle. And also PSQ are both 90 degrees. Also, I can see that PRQ, this is going to sound silly, equals PRQ. So PRQ in the big triangle is equal to, you maybe actually call it SRQ, I think it makes more sense. SRQ, that angle there is the same in both. If two angles of a triangle are the same as each other, then the third angle must be the same as well. Therefore, all angles are the same. So triangles are similar. Question 15. Okay, special menu. 2 courses, starter and main, or main and dessert for $15.95. And we have that, blah, blah, blah. A restaurant has the above special menu available. How many different ways are there of choosing 2 courses, starter and main, or main and dessert? So the different ways you can have of choosing the starter and the main, so let's do that one. So if we just go starter and main, hopefully you can see the pattern. We could have soup with fish, chicken, pork, ribeye, or spaghetti. So that's 5 options. We could have Caesar salad with fish, chicken, pork, ribeye, spaghetti. Do you see the pattern? So that's 10. This is going to give me 15, and this is going to give me 20. So that then would be 20. Main and dessert, you can't see that. We could do it similarly. You could do whatever way you want to do it. So we can go fish with cheesecake, apple, ice cream, chicken, cheesecake, apple, ice cream, pork with cheesecake, apple, ice cream, and so on. So there's 5 of those and 3 of those, so that's going to be 15. So our answer then, 20 plus 15, and that gives us then 35. Rearrange the formula to make R the subject. This one can always be a wee bit messy, but let's see if we can get there. You can divide by 4/3. I think that's a wee bit tough, but I think it's nicer if we times everything by 3. If we times everything by 3, we get 3v is 4 pi r cubed. I hope you see what I've done there. This is currently 4/3 pi r cubed. If you times that by 3, you get 4 pi r cubed. We want to get the r on its own, so we're going to divide by 4 pi. So that gives me 3v over 4 pi equals r cubed. And if we have r cubed, how do we get r on its own? We've got to take the cube root. So that's us then, really. R equals the cube root of 3v all over 4 pi. The height of a balloon h varies directly as the square root of its surface area A. H equals k square root of A. When the balloon's surface area is 81, its height is 12. What is its height when the surface area is 144? This 81 and 12 help us work out the k. 12 equals k root 81. 12 equals the square root of 81 is 9, so it's 9k. So k then is 12 over 9, or if you want 4/3, or if you want then 1/3. So the formula we're going to be using is h equals 4/3 square root of a. That's our formula then to work this out. H is 4/3 the square root of 144. h is 4 over 3 upon 12. 12 divided by 3 gives me 4, times by 4 then gives me 16. So my answer then is 16.